Hello friends, welcome to my YouTube channel RF Design Basics. As we have studied circular waveguide derivation of field component in TE and TM mode, now we are going to discuss further on this circular waveguide. And in TE mode, we have found that the cutoff wave number is equal to P dash Nm by A, where P dash Nm was the solution of mth root of the Bessel function. So the cutoff frequency FCNM is given by Kc by 2 pi under root mu epsilon, and if I replace Kc with P dash Nm by A, we will get the function for cutoff frequency as P dash Nm by 2 pi A under root mu epsilon. Now this P dash Nm is required to calculate the cutoff frequency for each mode. Here N is also integer and M is also integer. So let us take few values of N and M and write down in the table. So here we have P dash N1. If N is 0, this value will become P dash 01. This is P dash 02. This is P dash 03. Similarly, this is P dash 11, P dash 12, P dash 13. So like that we have value up to P dash 23, and based on this value we can decide the cutoff frequency and calculate it. Similarly, for the TM mode, our solution was Pnm by A. So in this case it was the solution of derivative of the Bessel function. Here it is solution of the Bessel function. So here it is Pnm by A, and the cutoff frequency is given by Pnm by 2 pi A under root mu epsilon. So again we need to find out the Pnm value, and Pnm value for few values are given here from n equal to 0, 1, 2. So these are the values, and based on this value we can find out which one is the dominant mode in circular waveguide, and we can arrange it based on its cutoff frequency. Apart from that, the attenuation due to dielectric material in the waveguide is given by k square 10 delta by 2 beta, where k is the wave number, beta is phase constant, and 10 delta is the loss tangent. And attenuation due to conductor is given as alpha c equal to Rs by ak eta b into kc square plus k square divided by rho dash 11 square minus 1, where rho dash 11 is, if n equal to 1, rho dash 11 is 1.841, which we can see among these two tables is having the lowest value. So this mode TE11 mode is called as the dominant mode. So in circular waveguide the dominant mode is TE11, and hence the attenuation due to conductor is calculated for the dominant mode, where Rs is called surface resistance of the conductor, and this is given as omega mu naught by sigma square root. So this will be in terms of ohm, and we can arrange this in terms of increasing order of cutoff frequency as, first of all we have to see which one is having the lowest value. In T mode we have the lowest value is 1.841. so this mode TE11, here n equal to 1, 1. So TE11 will be the having the lowest cutoff frequency. Then from 1.841 we will see the next value. Here next value is 3.054, but before that we have another value here which is 2.405, which is lesser than 3.054. So the next mode will be TM01. Then after that we have value which is equal to 3.054. So next mode will be TE n equal to 2. So TE21. TE21. I am just writing T mode in lower side of the line and TM mode in the upper side of the line. Then from 3.054 next value will be 3.832 here, and here also 3.832. So these are the having same cutoff frequency. The modes are TE01 and TM11. So we can write TE01, TM11. So after 3.832 we have to see the next value. So the next value might be here for n equal to 3 also, since I have not written the complete value. So I am just stopping here and I have just written 1, 2, 3, 4, 5. First 5 mode. For all the modes in increasing order, we have to check all the values in the table. So we have to check for n equal to 3, 4, 5 and so on. Now we are going to solve one problem based on these things. A Teflon filled circular waveguide with A equal to 0.5 centimeter. That means radius of the waveguide is 0.5 centimeter and the material is Teflon. If the interior of the guide is gold plated, calculate the loss in dB at 14 gigahertz. Also find the first two propagating mode. So how we will start? We have to find out the first two propagating mode from these values. So we have already seen 1.841 is having the lowest value, so it is dominant mode, and if the P-N1 which is in the numerator will have the lowest value, it will have the lowest cutoff frequency. So we have TE11 and TM01, TE11 and TM01 as the lowest cutoff frequency. So the first propagating mode will be TE11 and we can find that value by P11 dash into 1 by root mu epsilon is C. So C divided by 2 pi A under root epsilon r. So we can write for 1 by under root mu epsilon equal to 1 by under root mu naught epsilon naught into epsilon r. This has become C by epsilon r. So this is how we have replaced this 1 by under root mu epsilon by C by under root epsilon r. So when we put the values, this value is 1.841 multiplied by C, 3 into 10 to the power 8 divided by 2 pi, and the radius is 0.5 centimeter means 0.005 meter. For Teflon, the epsilon r is 2.08. So here we can put 2.08 When you calculate, you will get 12.19 gigahertz. Similarly, for this is for TE11 mode. Now next is TM01 mode. So we have to take the value of P01 into C by 2 pi A under root epsilon r, and P01 is 2.405 3 into 10 to the power 8 divided by 2 pi 0.005 under root 2.08. The calculated value is 15.92 gigahertz. So the first two propagating mode is TE11 and TM01 having cutoff frequency 12.19 gigahertz and 15.92 gigahertz. Now, if this waveguide is operated at 14 gigahertz, only this mode will propagate because this frequency is more than the operating frequency. So this mode will not propagate. So at 14 gigahertz, only TE11 mode propagates. And we can calculate the dielectric and conductor loss as we know the formula alpha D equal to K square 10 delta by 2 beta. And for this we have to calculate the K square value, which is wave number, and we know that K equal to 2 pi F epsilon r by C. So for this, first calculate K, and K is given as 2 pi F by C under root epsilon r, and if you calculate, you will get 422.9 per meter. This is the wave number. And similarly, you can calculate the beta. Beta is K square minus Kc square square root, and Kc here we have to calculate for TE11 mode. Put the value accordingly and you will get 208 per meter. So the alpha D equal to K square, so 422.9 square divided by 2 into 208. We are calculating for dielectric material, so 10 delta is loss tangent due to Teflon, and that will be 0.004, which is the characteristic of material, and this calculation gives us 0.172 Nipper per meter. So this is dielectric loss, and same way we can calculate the conductor loss, and the conductor loss will be alpha C equal to Rs divided by AK eta beta Kc square plus K square divided by rho dash 11 square minus 1 Nipper per meter, where Rs can be calculated as omega mu naught by sigma square root. So omega is 14 gigahertz into 2 pi, mu naught is permeability of free space, and sigma is the conductivity of gold. By putting all this value, you will get 0.0367 ohm. So this is surface resistance, and when you put this value in the formula alpha C, this value you have to put at in place of Rs. A is radius, K is wave number, eta is 120 pi or 377 ohm, beta is phase constant we have calculated for alpha D, kc square also we have calculated for alpha d, k square also we have calculated, and this value is given as 1.841 square minus 1. So the calculated value is 0.0672 Nipper per meter. So the attenuation can be converted into dB per meter, and in dB it is equal to 0.583 dB per meter. Similarly, the attenuation due to dielectric is 0.172 Nipper per meter. So in dB per meter it will be equal to 1.49 dB per meter. So we can combine it together to get the total loss per meter, and the total loss per meter will be alpha D plus alpha C, which is equal to 2.07 dB per meter. Now if the length of line is given, we can calculate the total loss. Let's say the length of line is 30 centimeter, so total loss will be 2.07 multiplied by 0.3. 30 centimeter is 0.3 meter, which is 0.62 dB. So this is how you can solve problems based on circular waveguide. Thank you.